Okay, this is my 2.0 version of the robot, and some of the features were that it had a front and side sensor, which are essentially the same idea as our other robot. It had two small wheels for greater traction, and two separate motors which would allow it to turn. In the back, I have a recreation of a ball bearing, which allows it to turn much more smoothly and evenly. In the front, I have a sled that would push robots. It has two modes, like this, which would slide the other robot up, or like this, which would push the other robot.
This is my version 2.0, my mini robot. I had a similar idea as Andrew to create a sled so that this is for pushing if I want to push the robot, and this is for when I want the robot to climb up. And the reason I put the plates here was to make sure that this was smooth, because usually the surface of a Lego piece on the top has little bumps on it, and if a wheel got stuck on there, it wouldn't really help because it would just come straight back down. So I made this smoother so the robots could stay there. The algorithm I used for my robot was that when it sent something, the front sensor, it would move forward and to the robot, and when it sent something, the side sensor, it would turn right so that it would be facing the robot, and that's when this sensor would come into play. And the gear ratio was very high, and that created a lot of speed because, oh my god, okay, because with high gear ratio, the speed is increased. You can think of it as a big gear to a small gear makes the gear ratio high, and with a gear ratio lower than 1, you have a torque robot, and a gear ratio greater than 1, you have a speed robot. And I included a speed robot because I thought that if my robot was fast, it would be able to ram into robots really quickly. But when I tried it, my robot didn't move, and it just kept turning in circles, and I never fixed it. Okay, I'm done.